Imagine you are driving on a highway. There's no traffic lights, there's no accidents, there's no cops, no whatever, right? Everyone is happy. Suddenly, just like this, the cars slow down. You run into a traffic jam, right? If you're like me, you'll be wondering, where's the jam coming from? And also, should I change lane? All right? So let's build a model to understand this. All right? In our model, we say, well, the driving velocity is a function of headway, which is the distance between you and the driver in front of you. All right? Without a doubt, it should be an increasing function of headway, right? Just like this. And also, you want to keep a safe distance to the driver in front of you. So push the curve to the right a little bit. And then for those of us who cares, we also want to drive under the speed limit. Okay? And for the math nerds out there, if you know the velocity, if you integrate the velocity, you get the position. All right? So we can visualize the position by visualizing them in a computer program. All right? So now, all of the cars, they start from a non-uniform headway. All right? When time goes, you see that according to our model, they'll come back to a uniform headway. Right? No jam forms. Right? So where's the jam coming from then? In reality, really your velocity is not a function of headway. Instead, it's a function of what we call perceived headway. What is perceived headway? It's the headway based on where you think you are, right? But because everyone has finite reaction time, this is where you actually are. And if you're driving at a different velocity than the driver in front of you, then the perceived headway will be different than the actual headway. All right, so we can put this in our model again, and then to visualize what's going on. So now you're seeing all of the cars, they start from more or less same headway. And then over time, you see this kind of wave forms, and the wave propagates. And if you focus on driver number 8 and 9, I think, give it a second, they'll crash. All right, so jam forms, and collision happens, okay, because of reaction time. So that's pretty bad, all right? Now we're thinking, well, should I change lane though, right, if I want to avoid traffic jams, right? How do I model lane change? Why do you want to make a lane change? For me, it's because I'm frustrated by the current lane, all right? So the higher the frustration, the more likely I'm going to change lane. All right, so how do I accumulate frustration then? In our model, there are two ways. All right, one, if I see a better headway in the next lane, right, then I think I can drive faster there, so I want to change lane. All right, or I'm getting passed by a lot of cars, my frustration will also build up. Right, so these are the two ways the frustration will build up. Then we can put these in our model again. Now we can model multiple lanes. All right, now we have two lanes, and all of the cars that are the same, they have the same headway, and make the simulation run. What you see here is that no frustration build up whatsoever for any driver, right? No one actually changes lane. That's fine, right? That's great. Now, if I introduce another type of driver, right? Car number 1 now is what we call aggressive driver, right? Who wants to tailgate more, all right? So here, you see that car number 1 tries to go a little faster, and then frustration starts to build up, right? Not only for driver number 1, for every driver. For every driver, the frustration build up, and then every driver tends to change lane. All right? So lots of lane changes and their source of accidents, right? And according to our simulation, the aggressive driver there actually doesn't have any speed limit, any speed gain there, right? But he actually makes 4 times as many lane changes as the other. Okay? So here are the 2 lessons we learned. So drive sober, stay in your own lane. Thank you.